Okay, this is Mrs. Black. We have a 25 kilogram block resting on a hill with a friction of 45 newtons against it, and the hill has an elevation of 30 degrees, so it's accelerating down the hill. All right, the first thing we would like to know is what are all the forces, and then we'd like to find out what the acceleration is. So if we draw the normal force perpendicular to the surface, the frictional force parallel to the surface, and the gravitational force straight down towards the center of the earth, and then we can draw from the tail of the first to the tip of the last the net force vector. All right, then we can look at some of the forces and some of the areas here. We can call this X, and then we remember that the angle of elevation of the ramp, that's this angle here, 30, is the same as the angle between the normal and the gravitational. And so we'll just make that 30, that makes this 60, that makes this 90. And so the ratio of the sides is 1 to square root of 3. All right, so the first thing I'd like to know is what the normal force is. So the ratio of the normal force is square root of 3. And then I would need the gravitational force is to 2, so I need to calculate that. Remember, you cannot convert mass into any force. However, you can calculate only gravitational force using mass. So 25 kilograms times 10 newtons per kilogram is 250 newtons. So this is 250 newtons. Therefore, this is 250 newtons. Okay, so then 250 divided by 2 is 125. 125 times square root of 3 with my calculator is 216.5, so I can just call this 217. So this is 217 newtons is the normal force. Okay, then if I want to look at X, X is to 1 as 250 newtons is to 2, so X equals 125 newtons, and X minus the friction, which I did not write in, that's 45 newtons. That's going to be equal to the net force. So 125 newtons minus 45 newtons equals 80 newtons. So that is the net force. All right, so then acceleration is equal to net force over mass is equal to 80 newtons over 25 kilograms. So calculate that out using my calculator, and I get 3.2 meters per second per second. All right, and then there's all kinds of ways you can go with kinematics from there, or what if the friction were this, then what would the net force be? Things like that. All right, but that's the basic how you do this.